Mastering the Raspberry Pi 5. Welcome back to the channel, everyone. Today, we're diving deep into a device that's completely shaking up the single-board computer world, the Raspberry Pi 5. Forget what you thought you knew about hobbyist boards. This is a serious piece of engineering that redefines what's possible on a budget. We're going to explore how this powerhouse is not just an upgrade, but a gateway to projects you've only dreamed of. The generational shift. So let's get right into it, because the jump from the Pi 4 to the Pi 5 is less of an upgrade and more of a paradigm shift. This isn't just about a faster clock speed. It's a fundamental re-architecture that delivers a massive 2-3x performance increase across the board. The key question is how this redefines what a single-board computer can actually do for you. What real-world problem does this new power actually solve for a maker or developer? This power unlocks projects that were previously frustrating or impossible, like real-time object detection on multiple high-resolution camera feeds without a dedicated accelerator. You can now build a proper home media server that transcodes 4K video on the fly, something the Pi 4 struggled with immensely. It also makes running a full, responsive desktop environment a genuinely smooth experience, not just a novelty. How does this massive performance increase change the reputation of the Raspberry Pi in professional circles? This performance jump elevates the Pi from hobbyist gadget to a viable light industrial and commercial tool. We're seeing them deployed as robust network controllers, thin clients, and even in Kubernetes clusters for development and testing. For professionals, it's no longer just a tool for learning. It's a cost-effective device for building and deploying real-world applications. The custom-built brain. One of the biggest stories of the Pi 5 is that Raspberry Pi is now designing its own custom silicon, moving into the same league as giants like Apple. This means they control the entire pipeline, creating chips specifically tailored to the board's needs. The result is a level of integration and performance that you simply can't get with off-the-shelf parts. Why is the new power management IC with its real-time clock such a game changer? The new power management IC, or PMIC, is a game changer because it enables the Pi to draw more power reliably, up to 25 watts via USB-C power delivery. This is critical for powering demanding PCIe devices and multiple high-power USB peripherals without needing a separate power hub. It's the foundation that makes the Pi 5 a true desktop replacement and a versatile server. The PCIe gateway. All right, let's talk about the feature that has everyone excited, PCI Express. That tiny, unassuming FPC connector on the side of the board is a direct, high-speed lane into the Pi's processor. This opens the door to a whole universe of professional-grade accessories that were previously exclusive to big, expensive PCs. What does having PCIe on a Raspberry Pi actually mean for a home project builder? For a builder, PCIe is like adding a standardized, universal expansion port to your project. It means you're no longer limited by the speed of USB for your peripherals. You can now connect NVMe SSDs for lightning-fast storage, multi-port 2.5G Ethernet cards for a custom router, or even dedicated AI accelerators for machine learning tasks. How does one practically connect an NVMe SSD, and what is the tangible benefit? You'll need an adapter, often called an M.2 hat, which converts the Pi's FPC connector to a standard M.2 slot. The benefit is staggering. Booting your OS from an NVMe SSD can take less than 10 seconds, and applications load almost instantly. This completely eliminates the storage bottleneck of microSD cards, making the entire system feel incredibly responsive. You mentioned an unofficial Gen 3.0 speed. What is the story behind that? The Pi 5 is officially certified for PCIe Gen 2.0 speeds, which is about 500 megabytes per second. However, you can unlock Gen 3.0 speeds, doubling the throughput to nearly 1 gigabyte per second by adding deparum equals gen equals 3 to your /boot /firmware /config.txt file. While this isn't officially supported, it's been found to be stable with most devices and provide a massive performance boost. What is the biggest mistake someone can make when adding a PCIe device to their Pi 5? The single biggest mistake is inadequate power. Most PCIe devices, especially NVMe drives, require more power than the FPC connector can supply. You must use a PCIe adapter hat that has its own separate power input to avoid system instability, data corruption, and potential damage to your Pi. Beyond storage, what is the most exciting type of PCIe card one can connect to the Pi 5? Beyond storage, the most exciting accessories are multi-port 2.5 gigabit or 10 gigabit Ethernet cards, which let you build an incredibly powerful custom router with software like OpenWRT. Another fascinating area is using Google Coral AI accelerators over PCIe. This allows for high-speed, low-latency inference for complex machine learning models directly on the Pi. A modern operating system. The software has also been rebuilt from the ground up with a new Raspberry Pi OS based on Debian Bookworm. This isn't just a fresh coat of paint. It's a move to a modern, more secure, and higher performance software stack. The switch to technologies like Wayland and Pipewire makes the desktop experience significantly smoother and more capable. Why was the switch from X11 to the Wayland display server necessary? The switch to Wayland was about security and performance, moving away from the decades-old X11 system. Wayland's modern architecture isolates applications from each other, preventing them from snooping on one another, which is a huge security win. It also eliminates common graphical glitches like screen tearing, providing a much smoother visual experience, especially with video playback in games. For a remote user, what is the most important thing to know about using VNC with Wayland? The key is to forget traditional VNC servers and use one design for Wayland, like Wave. You can install it with sudo apt install Wave, run it from the terminal, and set a password. Then, you can connect with a standard VNC client, like Tiger VNC, for a stable, secure remote desktop session. How does the new Pipewire audio server improve life for someone creating a media player or retro gaming machine? Pipewire is a unified audio and video server that drastically reduces latency and improves compatibility, especially with Bluetooth audio devices. For Media Center, this means your audio syncs perfectly and connecting headphones is a seamless experience. It replaces the old, complex audio stack with a single, modern solution that just works. Beyond the official OS, which alternative operating system excites you the most for the Pi 5 and why? For server applications, Armbian is a fantastic choice as it's often leaner and more optimized for headless operation. For those familiar with the ecosystem, Ubuntu now offers official desktop and server images that are very well supported. And for turning the Pi 5 into a powerful smart home hub, Home Assistant OS is the undisputed champion. What is network booting and how does it transform managing a cluster of multiple pieces? Network booting, or PXC, allows a Pi to boot its operating system directly from a central server over the network, without needing a micro SD card. For anyone managing a cluster of Ps for a lab or a server farm, this is transformative. It means you can update the OS image in one place and have all your Ps boot the new version instantly. Pushing the limits. Now, for those of you who want to squeeze every last drop of performance out of your Pi 5, we have to talk about overclocking. This isn't just for bragging rights. It's about understanding the hardware's limits to optimize it for demanding tasks. With the right cooling, you can get a significant, stable performance boost for free. What is the single most important file a Pi 5 owner needs to understand to tune their device? The single most important file is /boot/firmware/config.txt. This is the low-level control panel for your Pi's hardware, allowing you to adjust CPU frequencies, voltages, and enable or disable specific hardware features. Mastering this file is the key to unlocking your Pi's full potential. Can you give us a safe, step-by-step analogy for a beginner to approach overclocking? First and foremost, active cooling is not optional for overclocking. It's a requirement to prevent thermal throttling. Start by increasing the CPU frequency in small increments in your config.txt file. For example, setting arm_frequency equals 2800 for 2.8 GHz. Then, run a stability test like stressing while monitoring the temperature with veg measure_temp to ensure it stays below 80 degrees Celsius. What does the over_voltage_delta command actually do to the chip? The over_voltage_delta command gives the CPU core a slight, controlled voltage boost, measured in microvolts. For example, over_voltage_delta equals 50,000 increases the core voltage by 0.05 volts. This extra voltage helps stabilize the processor at higher frequencies, but should be increased cautiously as too much can generate excess heat. How can you tell if your overclocking is stable or if you are damaging the Pi? The key indicators of an unstable overclock are system freezes, random reboots, or application crashes, especially under heavy load. You can also check for throttling with the command get_throttled. A non-zero value indicates the CPU has reduced its speed due to heat or low voltage. A stable overclock should survive a multi-hour stress test with no errors and no throttling. Why is a high-quality A2 rated microSD card more important now than ever before? The Pi 5's I/O system is so much faster that the storage itself has become the bottleneck. A high-quality A2 rated microSD card provides significantly higher random read/write speeds, which is crucial for a responsive operating system. Using a cheap card on a Pi 5 is like putting economy tires on a race car. You're crippling its potential. The ultimate home server. With the power of PCIe, the Raspberry Pi 5 can finally be the heart of a truly capable home server or NAS. We're moving beyond simple file sharing into a world of self-hosted applications, media streaming, and personal cloud services. This is about building your own private, powerful, and versatile digital hub without the high cost of commercial systems. How would you design the ultimate Pi 5-based NAS for a family's photos and media? For the ultimate setup, you'd boot the OS from a fast NVMe SSD connected via a PCIe M.2 hat. For bulk data storage, you'd use a separate PCIe to SATA adapter card, connecting it to several large hard drives. This entire system can then be housed in a proper NAS case with an ATX power supply, providing stable power to all components. Why would you choose ZFS over a traditional RAID setup for data safety? ZFS is a modern, advanced file system that prioritizes data integrity above all else. Unlike traditional RAID, which can silently pass on corrupted data, ZFS has built-in checksums to detect and even correct bit rot or silent data corruption. For protecting irreplaceable data, like family photos, ZFS provides a level of security that older file systems simply can't match. What is a ZFS snapshot, and how can it save you from a disaster? A ZFS snapshot is an instantaneous, read-only copy of your entire file system at a specific moment in time. If you accidentally delete a critical folder or get hit by ransomware, you can roll the entire system back to the state of the snapshot in seconds. It's the ultimate undo button for your data, offering peace of mind that backups alone can't provide. How does using Docker for services like Plex or Nextcloud make an NAS more robust? Docker containers are like lightweight, isolated virtual machines for your applications. Running services like Plex or Nextcloud in containers means their dependencies and configurations are completely separate from the host system and each other. This makes your NAS incredibly stable, secure, and easy to maintain or migrate. Can you give an example of a simple Docker Compose file for a popular service? A basic Docker Compose.yml 4plex is like a recipe card for your service. It defines the image to use, like Linux server/plex, sets the network underscore mode to host for easy discovery, and maps volumes for your configuration and media files. Finally, a restart. Unless stop policy ensures your media server automatically comes back online after a reboot. What is Open Media Vault, and how does it simplify the process of building a NAS? Open Media Vault, or OMV, is a free, open-source software suite that turns your Raspberry Pi into a professional-grade NAS with a simple, powerful web interface. It handles all the complex setup for you, from managing storage pools and users to configuring services like SMB, FTP, and Docker. It's the easiest way to get a feature-rich home server running with minimal command line work. The Intelligent Edge Device. The Pi 5 is powerful enough to become the brain for your smart home, moving beyond simple automation into the realm of intelligent edge computing. By adding specialized hardware, it can analyze data locally without relying on the cloud. This makes your smart home faster, more private, and more reliable. How does adding a Google Coral TPU turn the Pi 5 into a dedicated AI machine? Adding a Google Coral TPU via M.2 or USB turns the Pi 5 into a highly efficient AI inference engine. The TPU is a specialized chip designed to run machine learning models, offloading that complex work from the main CPU. This allows the Pi to perform high-speed, real-time object detection or other AI tasks while consuming very little power. Can you paint a picture of how Frigate NVR with a Coral TPU changes home security? Frigate NVR completely transforms video surveillance by using a Coral TPU for real-time AI object detection. Instead of getting hundreds of false alerts from shadows or swaying trees, Frigate only records and notifies you when it identifies specific objects like a person, car, or animal. This makes your security system genuinely intelligent and drastically reduces notification fatigue. What kind of powerful networking device can you build with a Pi 5 and a multi-port Ethernet card? With a multi-port 2.5G Ethernet PCIe card and a supported OS like OpenWRT, you can build a router that rivals or even surpasses expensive prosumer models. You get full control over your network with features like VLANs for network segmentation, advanced quality of service to prioritize gaming traffic, and a powerful VPN server. It's the ultimate tool for taking control of your home network. What is one advanced feature from OpenWRT that could completely change how someone uses their home internet? A great example is setting up quality of service, or QoS, to prioritize traffic for specific devices or applications. You could create a rule in OpenWRT that always gives your work laptop and gaming console priority bandwidth over other devices. This can eliminate lag during important video calls or online gaming sessions, even when other people are streaming video on the same network. What is the real story with trying to connect an external GPU to the Pi 5? Connecting an external GPU, or eGPU, is the final frontier for Pi hacking, but it remains highly experimental. The main challenge is the Pi's kernel not allocating a large enough base address register, or bar, space for most graphics cards. While some progress has been made with older AMD cards, it's not a practical solution for gaming or serious GPU acceleration yet. The hidden superpowers. Beyond the headline features, the Pi 5 has some incredible capabilities inherited from its microcontroller cousin, the RP2040. These hidden superpowers, like the programmable I/O blocks, are not immediately obvious but unlock a new level of control for advanced hardware projects. They allow you to create custom interfaces and offload precise, high-speed tasks from the main CPU. What are the programmable I/O blocks, and what kind of magic do they enable? The programmable I/O blocks, or PIO, are like two tiny, ultra-fast coprocessors living inside the RP1 chip. You can write small, efficient state machine programs that control the GPIO pins directly, independent of the main CPU. This allows you to create any custom digital interface you can imagine, from driving NeoPixels to reading data from obscure sensors with perfect timing. How does PIO solve the classic problem of driving NeoPixel LEDs? PIO solves the NeoPixel problem by offloading the precise, time-sensitive signal generation to a dedicated hardware state machine. You write a tiny PIO program that generates the exact waveform the LEDs require, and the main CPU simply pushes the color data to it. This allows you to control thousands of NeoPixel LEDs flawlessly with zero CPU load, something that's nearly impossible with software alone. How can someone use the dual camera ports to give their robot 3D vision? By connecting two identical cameras to the Pi 5's dual MIPI CSI ports, you can perform stereo vision to perceive depth. Using a library like OpenCV, you first calibrate the cameras to understand their exact positions and lens characteristics. Then, the software can compare the images from both cameras to create a disparity map, which is essentially a 3D point cloud of the scene in front of the robot. What is the single most useful feature of a headless setup for a developer? The dedicated 3-pin UERT debug port is an absolute lifesaver for headless development. It provides direct, low-level serial console access to the SoC, even during the earliest stages of the boot process. This means that even if your network or video output fails, you have a reliable backdoor to diagnose problems and manage the device. Virtualization. Why is the ability to run KVM virtual machines on a Pi 5 so significant? The Pi 5 is powerful enough to run kernel-based virtual machines, or KVM, which is a true hardware virtualization solution built into the Linux kernel. This allows you to run multiple, completely isolated operating systems on a single Pi with near-native performance. It's perfect for creating secure sandboxes for testing untrusted software or experimenting with different Linux distributions without affecting your main OS. How would you explain a K3s Kubernetes cluster of Pi 5s to a beginner? A K3s Kubernetes cluster is like a well-organized, self-healing team for your applications. One Pi acts as the server node, or the manager, which keeps track of what needs to run. The other agent nodes are the workers that actually run your containerized applications, and the manager automatically distributes the work and handles any failures. The democratization of technology. Ultimately, the Raspberry Pi 5 represents a profound democratization of technology. It packs enough power for serious computing, server applications, and AI into a $60 package that's accessible to almost everyone. This isn't just about making things cheaper. It's about lowering the barrier to entry for learning, innovation, and building the future. Looking at all these features, what is the single most profound impact the Pi 5 will have on technology access? This level of accessible power means a student in a classroom or a tinkerer in their garage now has the same compute capability that would have cost thousands of dollars just a few years ago. They can learn AI development, network engineering, or robotics on a real, capable machine. This hands-on access is what sparks curiosity and creates the next generation of engineers and innovators. If the Pi 5 is this powerful, what does the future Compute Module 5 mean for the world? The Compute Module 5 will take the power of the Pi 5 and place it into a rugged, compact form factor design for industrial and commercial products. Imagine intelligent security systems, custom factory automation controllers, and next-generation digital signage, all powered by this affordable and powerful module. It's going to fuel a massive wave of innovation in the embedded systems market.